This is an example of various word problems where a natural exponential function is used. Number one, suppose that the velocity in meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where the time is measured in seconds. How many seconds after diving will the skydiver's velocity be 51 meters per second? So we have v equals 51, and we need to find t. We're not supposed to round any intermediate computations. We're only supposed to round at the very end to the 10th. So plug in 51 instead of v. 67 minus 67 e to the negative 0.19 t. First thing you're going to do is subtract 67 from both sides. 51 minus 67 is negative 16. Negative 67 e to the negative 0.19 t. Then we're going to divide by the negative 67. Now negative 16 divided by negative 67, negative by a negative, will give you a positive result. So this is just 16 over 67 equals e to the negative 0.19 t. Please do not put 16 over 67 into your calculator. We do not want a decimal here. We want a fraction. Fractions are exact. Decimals are approximate. Now we're ready to actually convert this equation into a logarithmic equation to get t out of the exponent. So base is e, so this is a natural log ln of 16 divided by 67, and it equals negative 0.19 t. In order to get t, we just have to divide by the number in front of the t. Now putting this into a calculator and rounding to the nearest tenth, we get 7.5 seconds. Number two, the number of milligrams of a certain drug that is in the patient's bloodstream 8 hours after the drug is injected is given by the following function. When the number of milligrams reaches 14, the drug is to be injected again. How much time is needed between injections? So this time D is 14 and we need to find H. So plug in 14 for D equals 45 e to the negative 0.27h. We're going to start by dividing both sides by 45. 14 divided by 45 equals e to the negative 0.27h. Now we're ready to convert to a logarithmic expression. It's still base e, so ln of 14 over 45 equals negative 0.27h. And then all we have to do is divide by the number in front of h. So divide by negative 0.27, put it into a calculator and round to the nearest tenth. This is 4.3 hours. Number three, a radioactive substance decays according to the following function, where Y naught is the initial amount that's present, and Y is the amount present at the time, T in days. So T is measured in days. Find the half-life of this substance. Do not round anything in between, just round the final answer to the nearest tenth. So for this one, we're actually dealing with half-life. Half-life means that when we are talking about initial and the current amount, half-life means that the current amount is the same as half of the original amount. Well, for us, the current amount is Y. The original amount is Y naught. So the current amount Y equals 0.5, half of the original amount Y naught. So now knowing this, we can plug that into this formula right here and calculate the half-life. So instead of y, I'm going to plug in 0.5 y naught equals y naught e to the negative 0.019 t. Now we can divide by y sub 0, y naught on both sides. So that's just 0.5 equals e to the negative 0.019 t. Now we're ready to go ahead and convert this to a logarithmic equation base e. So this is ln of 0.5 equals negative 0.019 t. And then we'll just have to divide by the number in front of t. T equals ln of 0.5 divided by negative 0.019. Put it into a calculator and round it to the 10th. So this is 36.5 days. And number 4, in this time, instead of half-life, we have doubling time. The amount of money invested in a certain account increases according to the following function, where y naught is the initial amount of the investment and y is the amount currently present in the account after t years. So after how many years will the initial investment be doubled? So this time, doubling time means that the current amount that you have is twice the original amount. So current is represented by y. The original is represented by y naught. So y equals 2 times y naught. So that's what I'm going to do here. I'm going to substitute this y with 2 of the initial amounts. So 2 times y naught equals y naught e to the 0.048 t. We can divide by the y sub 0, y naught on both sides, just leaving you with 2 equals e 0.048 t. After that, we can go ahead and switch to a logarithmic equation, base e, so ln of 2 equals 0.048 t. And then t is ln of 2 divided by 0.048. Calculator and round to the 10th.